Hello and welcome to today's lecture, which is on the compulsory and optional canons of notation as propounded by Dr. Ranganathan. I am Mustafa Zaidi. I have been teaching library science in the Aligarh Muslim University for 3 decades and I have also worked in libraries. Now, in previous discussions, we have considered the ideas of Dr. Ranganathan and other stalwarts of the field of classification, and we are now discussing in detail Dr. Ranganathan's concepts. Now, Dr. Ranganathan, as we all know, divided the work of designing a scheme of classification into 3 parts. The first part he called the verbal part, the first part he called the idea part, the second part was the verbal part, and the third was and is notation. He formally named them as idea plane, the verbal plane and the notational plane, and he formulated canons or rules for the observance of certain practices at the level of arrangement of subjects, which is the idea plane, at the level of naming of the subjects, which is the verbal plane, at the level of representing the subjects by symbols, which is the notational plane. In previous discussions, we have also looked at the idea of pure notation and mixed notation and faceted notation and non-faceted notation. Now, today's lecture, this lecture is concerned more with these ideas like the mixed notation and faceted notation, and how many symbols should be used in a class number, and how we can overcome the problem of remembering large class numbers. So, Ranganathan gave us, as we have discussed earlier, Ranganathan gave us 12 canons, and these 12 canons he divided into 2. There were 12 canons. There were compulsory canons and optional. There were 2 compulsory canons. There were 10 optional canons in 5 pairs. We have already discussed the compulsory canons. So, let us look at the optional canons today. The first pair is the canon of relativity, and this is contrasted, or this is against, the pair is the canon of uniformity. Remember that Ranganathan, when he was designing and when he was giving us these canons, was talking about books. We are now in an era where books, except in formal education and except for recreational reading, have nearly disappeared from our usage. Most of us now depend on computerized systems, and we try to extract information that we want through the net and through our libraries, which are equipped with tools for digital retrieval. But these things, these concepts that Ranganathan talked about are still relevant. They are relevant because they talk about the basic arrangement of knowledge and how that basic arrangement of knowledge can be represented by symbols, and how those symbols should be organized so that we are led by the sequence itself to the place that we are looking for. This is important for us to understand, as we all know that in our today's world, whatever we write on the screen of a computer or in our smartphones or any other place, anything which is digitally enhanced, there each one of these symbols or each one of these alphabets is represented by a series of symbols. And what are these symbols? They are represented by, I am digressing slightly, they are represented by what we call binary digits, meaning they are represented only by 0 and 1. So, C for example, when the computer stores it, it is not stored as C, it is stored as a series of 0. This is just a representation, it is not real, something like this, meaning this one symbol, one alphabet is represented by, let us say, so many symbols, and this combination of the symbols tells the computer that what you have to output is C and what has been input is C. So, if you look at it closely, or if you think a little bit deeply about it, this is exactly what we are doing in the field of classification. For example, the subject economics is represented in one system, the system that is used in most libraries in India is represented by the combination of symbols 330. 330 means what? Economics. Why have we given this symbol 330 here? Because we want that economics should come along with political science, should come along with sociology, which should also start with 3. So, all social sciences, all subjects in social sciences start with 3 as the first digit. So, this helps us in mechanizing the arrangement. This is exactly what is being done in the field of computers today. Of course, this is invisible for us. We do not see this. This is inside the black box. What librarians do is outside, but the basic concept is the same. That is why Ranganathan's ideas on relativity and uniformity and extensiveness and under extensiveness, they are still relevant, whereas you might say that they were made for the realm where books and printed books and magazines were the basic sources of information, and now we have other sources of information, but the ideas behind arrangement of knowledge or organization of knowledge are still relevant. So, the canon of relativity stated that in any class number or in any isolate number, we have already discussed what is a class number and what is an isolate number. A class number is a subject, an isolate number is an idea within that subject. So, it says that in any class number or in any isolate number, there should be the length of the class number should be relative to the level of detail in that subject, meaning what? That if you have, let us say, we have social sciences, then one of the divisions of social sciences is economics, one of the divisions of economics is labor, one of the divisions of labor is unskilled labor. So, if social sciences is being represented by, let us say, 3, economics is being represented by 3, then labor economics should be represented by 3, 1, unskilled labor should be represented by 3, 2. As you go down, what are you saying? You are saying that the number of digits is increasing depending upon the level of the concept which is being represented. Social science is a broad concept, it is being represented by 3, meaning one symbol. Economics is subordinate to this, it is being represented by 2 symbols. Labor is still subordinate or is still of a greater depth, it is being represented by 3. Unskilled labor is a further subdivision, so it is being represented by 4 symbols. Now, it is not necessary that you should have 3 here and 3 here, and we could have used two here, I am sorry. You can use any symbol that you want, but the canon of relativity says that as you move down a chain, as you move down a group of concepts which are each subordinate and superordinate to each other, then the length of the class number should keep on increasing. The canon of uniformity is the exact reverse of this. It says that the number of digits in a class number or the number of digits in an isolate number should be uniform. What does that mean? That if you are representing social sciences by 2, then you can represent economics by 3, you can represent labor by 4, you can represent skilled by 5. These are of different levels, but the number of digits in the class number is the same. And since if we are using mixed notation, what we can do very easily is that you represent to represent social sciences, you can use C to represent economics, you can use D to represent labor, and you can use F to represent unskilled labor. Here again the number of symbols is the same. That means the canon of uniformity is being followed. Now, why were these two alternatives given by Ranganathan? Because Ranganathan said that there is, if you are making a classification scheme for a small subject or for an area which is does not have a very large number of variations, then it is much better that you use the canon of uniformity, because then people get used to a set of symbols, that these 3 symbols will represent the subjects that we want, and you can get all of them. In the canon of relativity, as you go down, as more and more details are worked out, then the length of the class number keeps on increasing, which becomes difficult for people to remember. So, depending upon the exigencies of the situation, depending upon which area of knowledge you are trying to classify, you can use either the canon of relativity or the canon of uniformity. But once you have decided on a particular method, then what the canon says is that you should stick to that. Otherwise, go for a thorough revision and try to change everything. So, if once you have adopted relativity, you should always use relative numbers. Once you have adopted uniformity, then you should always use uniform numbers. So, this is the first pair of canons. The second pair of is the canon of hierarchy versus the canon of non-hierarchy. The canon of hierarchy says that as you move down a chain meaning a group of concepts, each one of which is subordinate to the previous one. As you move down a chain, there should be a digit to represent each of the previous links in that particular hierarchy. The canon of non-hierarchy says it is not necessary that you should add a number to represent anything which has come earlier. But this seems similar to the first pair that we have studied, canon of relativity versus canon of uniformity. But in the canon of relativity, what they were saying was that you should add one symbol or the number of symbols in a class number or isolate number should be equal to the level of that class, meaning that if you are using one symbol to represent a particular class, then at the next level there should be 2. If you are using 2 numbers to represent a class, then at the next level there should be at least 3. In the level below that, there should be 4. Here more detail has come in. Once you have adopted relativity, you can also decide to use what is called as hierarchy. What does that mean? What it means is that if you are using, let us say, three, 4, 0 to represent chemistry, then you should use 3, 4, 1 to represent inorganic chemistry. As you know, we are using decimal notation. This 0 does not have any value. It is a 3-digit number, but it has no value. it is basically 3 4. Since we are using a decimal, this number is a decimal number, therefore, the practice is that we do not write the decimal at the beginning or at the left of any number. Now, in inorganic chemistry, 3 represents what? 3 represents science. 3 4 0 or 3 4 represents chemistry. Inorganic chemistry has 3 symbols. 3 represents science, 4 represents chemistry, and 1 represents inorganic chemistry. If you have, let us say, oxygen, then oxygen is what? Before oxygen you have the elements. So, the number for elements should have 3 to represent science, 4 to represent chemistry, 1 to represent inorganic chemistry, and let us say 1 to represent elements, and oxygen will have 3 4 1 1 5. This 5 represents what? Oxygen. The 1 represents what? Elements. This 1 represents what? Inorganic chemistry. This 4 represents what? Chemistry, and this 3 represents what? Science. So, this is the canon of hierarchy. The class number that you have, and if you look back or try to reflect on the books that you see in the library, then most of our libraries are arranged by systems which try to follow the canon of hierarchy. If this was, if you were using DV, then instead of 3 here, you would have found 5 to have been the main symbol. 5 for 0 means chemistry in the DV system, and 5 for 1 means inorganic chemistry, and so on. If you are using the colon system, then this would have been, E would have represented chemistry, and E1 would have represented inorganic chemistry, and elements and oxygen would have been represented by E1 something, and oxygen would have been represented by E1 and 1 6 maybe. I am not very sure about it, but what I am trying to tell you is that if you are following the canon of hierarchy, then the number of the parent class is repeated in the number of the progeny class, meaning whatever class comes later, that repeats the numbers of the previous link. The canon of non-hierarchy says that this is not necessary. If you want, you can repeat the symbols which have occurred in the previous links. If you do not think it feasible, then do not repeat them. Still your classification schemes would still work. Now, why is it that this canon of non-hierarchy has been given? The reason, as we have also discussed in a previous class. So, canon of hierarchy, to sum up, I would say that canon of hierarchy says that you should represent the number of the parent class in the number of the progeny class, meaning if we are moving down a chain like this, if we are moving down a chain, let us say world, then Asia, then India, if we are moving down like this, world, then Asia, then India, then UP, then Meerut, we know that these are all subordinate. Asia is subordinate to world, India is subordinate to Asia, UP is subordinate to India, and Meerut is subordinate to UP. So, if we are representing world by, let us say 1, then Asia should be represented by at least 2 digits, that is the canon of relativity. But the canon of hierarchy says that repeat the number for world and then use the number for Asia. The canon for hierarchy says that in the number for India, the first 2 digits should be of the previous class, and then you can use a number to represent India. Canon of hierarchy says that for UP, you should have a repetition of 1 4 4, because that is the parent class, and then some symbol to represent UP. For Meerut, 1 4 4 5 should be followed by a symbol for merit, whatever symbol you want to give. So, this is the canon of hierarchy. This is similar to the canon of relativity, but the canon of relativity does not ask you to repeat these numbers, repeat the numbers of the parent class. It says it should be just relative to the order of the class. If it is of a lower order, then you should give a lengthier number. Now, we all know one of the violations of the canon of hierarchy done by every scheme is that we know that the world is unique. So, if you use the symbol 1 for world, then the rest of that system 2, 3, 4, 5, 6, 7, 8, 9, they would not be used. Therefore, in most schemes what they have done is that they have not followed the canon of hierarchy as far as geographical divisions are concerned. What they have done is that they have given a symbol to Asia, a single digit to Asia, but after that they have started following the canon of hierarchy. We will look at some more examples in detail a little bit later, and so that you understand what this basic concept means. Then the next pair of canons is concerned with another big problem. What is that problem? That problem is the capacity of notation, and this is sought to be solved by two opposite canons, the canon of pure notation to be discussed or considered along with Now, what does capacity of a notational system mean? We have discussed this concept earlier also, but capacity means the limit or the capability of a notational system to accommodate a number of classes. We know that the universe of subjects or the universe of knowledge is an ever growing and dynamic universe, meaning every day new subjects, new combinations of subjects occur, and they are represented in writings, they are represented in literature, they are represented in newer and newer publications. So, where do you keep these new things, because these subjects keep on growing and developing. So, capacity of a notational system means the total number of symbols that are available to you, so that you can represent them. In computer systems, the base or the number of symbols you have is only 2, that is why we call them binary. What are these two symbols? Zeros and 1. 0 is one symbol and 1 is the second symbol, that is all that we have, we do not have anything else. But in the system that we use, the Indo-Arabic numerals, how many symbols we have? We have 10. What are they? 0, 1, 2, 3, 4, 5, 6, 9. So, we have 10 symbols here. These 10 symbols can be used to represent all of the concepts that we have, provided we do not put a limit to the length of the class number or the number of digits in a class number. In computerized systems, since we do not see them, there is no limit. They have made limits which they call bytes, etc., to manage them, but the number of bytes that you have is unlimited. You can have any number of bytes. But what happens here is, as I gave you an example in a previous discussion, that for example, in phone numbers, the mobile phone numbers are difficult to remember. Why? Because there are 10 of them. It is difficult for us to remember them because human mind is not equipped to deal with such a large number of haphazard numbers. We can use these because we can pronounce them. We have provided sounds to all of them, and therefore, all of this we can pronounce, and this takes care of the structure of the language also. We use sentences that convey meaning. So, our problem is solved because of our unique abilities, but our unique abilities do not work if the sequence is haphazard, and if there is no way that we can simplify that concept. Notation is notation. If you have to remember this, and I will give you another example here. Let us say you have, if I have written this and you see it for the first time, not while I am writing it, but I suddenly give it to you, then you will have some difficulty in understanding what is this. Why? Because there are no spaces between the characters that I have made. A little bit of reflection will show that if you put in spaces here, then this is easily understandable as well as reproducible. We can reproduce this also. Why? Because now each one of these have been grouped into smaller sequences, and we know that where we have to take a break. Now, this is the problem, that when you put class numbers on the class numbers to represent subjects or represent classes, the length of the class number matters. And we have I have already told you that human mind and the physiology of the eye and the mind, we remember best sequence of 3 to 6 digits. Anything beyond this makes it difficult for many of us to remember the sequence. So, and a limit has been put in to the number of digits that we can use to represent concepts. The capacity of a notational system, therefore, is a function of two things. One is, it is a number of unique symbols that we have, and the length of numbers allowed, meaning how many digits do we allow. In a computerized system, we do not see them. So, there is no limit to the length. In an analog system, the limit is 3 to 6. You may stretch it to 7 or 8, but beyond that it becomes impossible for nearly every one of us. In the Indo-Arabic symbol system, the capacity or the number of unique symbols is 10. We have 10 unique symbols here, but the length of the numbers allowed will be, let us say 3, or let us say 6, or let us say 7. So, depending upon this, the capacity will increase or decrease. This is fixed, number of unique symbols is fixed. We have 10 symbols here, but how many do we allow? Do we allow 3? Do we allow 6? Do we allow 7? So, this is expressed by a simple mathematical formula, C, which is equal to B D, where C is capacity, B is base, base meaning number of unique symbols, and D is the length of the class numbers allowed. So, if the base is 0 is not used, 0 generally means nothing. So, let us leave 0 out of it. So, the base of an Indo-Arabic numeral system will be C is equal to 9, and if we limit it to 3, then 9 to the power 3. What does that mean? That means C is equal to 9 into 9 into 9. How many does that make? 9 nines are 81, 81 nines are 9 nines are 81. I am sorry, 72. So, 7 to 9 will be the number of concepts that we can represent if we are using only Indo-Arabic numerals, and we put a limit of 3, that not more than 3 things will be used. So, this becomes 729, that is all. So, this means that we can use a pure notation if our universe of subjects or the universe of knowledge that we are trying to classify is very small. If the universe of knowledge is large, then we will have to go in for mixed notation. So, these two canons or this pair of canons are only concerned with which symbols you should use, and Ranganathan has tried to provide a scientific basis through the use of what of this formula, and there is one more formula which is used to determine the capacity of a notational system. So, you decide whether you should use pure notation or you should use mixed notation. Similarly, we have the canon of, we have another pair, canon of faceted notation, and this is contrasted, or this is opposite to the canon of non-faceted notation. Now, we have already discussed earlier that facet means part, that since it is difficult for us to remember all set of symbols which is more than 6 digits long, therefore, librarians have experimented with attaching additional symbols here, such as a comma or a semicolon, or sometimes you can break it by 3, 6, 8, A, 4, 9, H, 2, 4. Now, introduction of this can serve as mixed notation. This also sometimes serves as what we call faceted notation. This distinguishes the part 3, 6, 8, A 49, H 24. So, we can remember this whole block with a little bit of attention, whereas if A is replaced by a number and H is also replaced by a number, then it will become nearly impossible for us to remember this for a significant for even for a minute. We will forget this sequence within a minute, because that is beyond the capability of a human mind normally. So, here also Ranganathan gave us formulas, and this formulas help us in determining whether we should use faceted notation or whether we should use non-faceted notation. So, this is important for us to understand. Then we have one more pair of canons, which is again seems similar to the first two pairs we looked at. This is known as the canon of coextensive class numbers or coextensiveness, and the canon of underextensiveness. The canon of underextensiveness and the canon of coextensiveness. These are also opposite canons. The canon of coextensiveness says that in a class number or in an isolate number, we should have digits to represent even the very last characteristics which has been used to derive that particular concept. Canon of underextensiveness is opposite to that. This says it is not necessary. Now, how do they differ from the first two pairs that we studied? They differ from the first two pairs in the sense that this canon talks of the fact that we should go on dividing a universe of knowledge until its last limit is used, and this should be expressed in the class number that we derive. Otherwise, if we do not go to that level of details, then we will be violating the concept of homonym, because the concept of homonymous class numbers mean that one number represents more than one concepts. That would be violated if we do not follow canon of coextensiveness. So, these are the 5 pairs of compulsory canons which Dr. Ranganathan has talked about. We can have another discussion on this in a subsequent discussion, but for the moment I hope you have understood why he gave us 5 pairs of opposing canons to whenever we decide to form a system of symbols. Thank you very much.